So our part 2 of exponents, we have a list of rules that we have to follow. So it's like basic anything. You have to kind of understand the rules before you can actually move on. And exponents has about roughly 7 rules that we need to go over, and I want to show you a handful of problems so you're not stuck with exponents. Exponents are used throughout the world, and I just want to kind of go through the rules and then go through that. So you have to kind of see that when you have an exponent, remember an exponent is something raised. So this is something raised. This is a 6. So this is what we call an exponent. So remember that if you have a base of say 2, remember this is an exponent is repeated addition. So I'm just making use of this. So going off of that, if I had 2 to the 6, that means I'm going to go 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5, 6. Well, 2 to the 6th power is going to be a big number. And that's part of exponents, is that it's really just taking something like, let's say 1,000, or let's say 1,000, and writing it as an exponent. Well, a better way of writing 1,000 could be this. 10 to the 3rd. Well, 10 to the 3rd, let's say, actually that's, 10 to the 3rd is 1,000. So let's go to these rules here. So our first rule is that if I have a to the m times a to the n, by the way, m and n are positive numbers. They're positive numbers. So like they can be anything you want. 1 to 1,000,000. But m and n are just positive numbers. So what's the rule when you are multiplying the same bases, the same numbers? Well, you see the exponents, so you have to have the same base. You have to have the same a. That's why a is written here twice. Well, when I say twice, it's there. So what I have to do, I have to remember that if I'm multiplying, this is a to the m plus n. You're going to add exponents. This is what you're going to add. These are division. So this is a to the n divided by a to the n. So this is going to be a, and you're going to subtract these. You're going to subtract exponents when you see division. When you have a power, a to the m raised to the n, this is going to be a m times n. Times. You're going to multiply exponents. When you have number 4, when you have a times b raised to the n, what that n is going to do is distribute. It's going to distribute to a and b, to the whole thing inside. Remember, there's a multiplication here. When you have a parenthesis, a over b to the n power of some sort, what's going to happen in this case is that this is going to go a to the n, b to the n. It distributes to the top and the bottom. Okay? Now, sometimes we have a to the 1st power. Well, how do you write a to the 1st power? A. How do you write a to the 0? A to the 0 power. Some number raised to the 0 power. Technically, this is just 1. There's a proof to that, but not for this class. And 0 to the 0 power is actually undefined. You can't actually raise nothing to something. Sorry, you can't raise nothing to nothing. Think about it. It's undefined. This is a rare occurrence. Okay? And then number 7 here says, I have a to the negative m. Well, over here, I told you that m and n are positive numbers. What that means is that I have to make this exponent positive. I gotta make this positive. How do I make it positive though? Well, what you're gonna do is do the reciprocal. You're gonna do the reciprocal. Okay? And I hope you know what the reciprocal is. For example, if I had 7 to the negative 1, to make this positive, 1 over 7. If I had 8 to the negative 2, to make this positive, I do the reciprocal. So I want you to think about this. When this is 1 over 7, think about this. There's a 1 under that. So when you do this, this is 1 over 8 squared, or 8 times 8 is 64. So these are your basic rules. And there's about 7 of them. You can probably put an 8 in there, but maybe that will be one of these. But really, technically, there's about 7 rules of exponents that I would like you to know, because they are the foundation of exponents. Okay? So I want to show you a handful of problems. Involves pretty much every one of these. So I want you to kind of get practice into these. So hopefully that works. So let's go ahead and do it. So remember your rules. So if you don't mind, take care of this. So let's do examples. Number 1. We're going to simplify. Oops. We're going to simplify. Simplify means get everything into its lowest terms. So this one, I'm going to have 8 to the 4th times 8 to the 3rd. So remember, when we had this, we have 8's, 8's. This is to the 4th, this is to the 3rd. Now you can sit here and you can go 8 times 8 times 8 times 8. So let's see, there's 4 8's times 3 8's. And then there's 4 8's. There's 3 8's. How many 8's do you have? 1, 2, 3, 4, 5, 6, 7. So happens that I don't want to keep doing this. I don't want to keep writing all these 8's, because what if you had 100? I'm going to sit here all day long and I'm going to go, I have to go like this. How many 8's do I have to write here? 100. And I don't have the chalk, I don't have the mindset to do that right now because I'm lazy. But is there a rule that makes this easier on me? And the question, yes, there is. So that rule was, if I have the same 8 base, I'm going to add the exponents. So this is 8, 4 plus 3. 8 to the 7th. I would not multiply this out. it would be a huge number. You don't need to multiply this out because that's pretty much what you have to do. You're just trying to simplify it. I don't want you to calculate it. If it was 8 to the third, 8 squared, maybe. But something like that, yeah. So, number 2. Try this one. Y squared times y to the 5th. That one there, well, the y's are the same. So I have this y, this y, and this y. They're all the same y's. So if this is, how many y's do I have to do here? 2. How many do I have to do here? 2. How many do I have to do here? 5. So I can write out all those y's, or I can do what I did up here when I have multiplication of the same base. So I'm just going to go y 2 plus 2 plus 5. 2 plus 2, 4 plus 5, 9. Now you could write out all those y's, but that's what it comes down to. Number 3. A to the third times a to the 5th times a to the negative 1. Okay? So, A, you're multiplying, add the exponents. So this is going to be a to the third plus 5, plus minus 1. So a, 5 plus 3 is 8. Minus 1, 7, right? So that's okay with negatives. You're probably thinking, wait. You have to do the reciprocal of this one. You have to do the reciprocal of this one. You're right. But you don't need to do that for multiplication. Okay? Try this one. 4 to the 4th, 4 to the 3rd. X to the 6th, x to the 4th. X to the 4th, x squared, y2. So each of these has a certain rule that is associated with it. So on this one, you have to go back to your rule set. These are both 4s, but this is to the 4th power. This is to the 3rd power. They're both the same, 4, but remember, what's our rule when we have division? We're going to take this top one and subtract that same bottom one. And this goes to 4. 4 minus 3 is 1. 4. Okay? This one, same thing. They're both x. This is 6 minus 4 x squared. This one here, there's x's and y's. That's okay. as long as you match them up. And here's one way you could do it. Remember, these are multiplication. Now, if you can't think about this, what I would do is split them up. So maybe you can go x to the fourth, x squared, times y to the third, y squared. What I just did is split them up for you. So you're not thinking, oh wow, that's a lot to handle. No, I want you to think about, hey, I know these rules. What can I do? So now if you split them up, you don't need to do this if you can see it. But I want you to understand this. So what do you do with these exponents? I'm not going to write them out this time. I want you to kind of look at the pattern. So this is x to the squared, y to the first. Okay. So there's just about a handful of problems, but I want to do some more that gets us a little bit more complicated, so we're not just doing some easy ones, because they get a lot harder. And as you're going through this, they don't get easier. So let's try this one. Let's see, this was 7. So a to the 5th divided by a to the 5th. Okay. So the first one, all right, number 7. So what are you going to do? A to the 5th divided by a to the 5th. Isn't this going to be a to 5 minus 5? A to the 0. What's any number raised to the 0 power? 1, right? Okay. Number 8. Uh-oh. Well, remember, this is parentheses. This is parentheses. This times this. This is 5a squared times b to the 3rd times 3a to the 4th times b to the 5th. Okay, this is when you have more than one rule that comes into play. So what I want to do is kind of split things apart. And as you get better at this, you don't need to do this anymore, but I want to show you this. So this is just extra work. So what I'm going to do is, I know this is multiplication. I'm going to go 5 times 3. 15, right? Okay. So that takes care of that. Well, I have a squared times a to the 4th. Remember what we do? Add the exponents. So that's going to be a to 2 plus 4, 6. B's. I have b to the 3rd, b to the 5th. What do I do with those exponents? I add them, right? So I'm going to go 3 plus 5, which is 8. And that's your only thing you need to do. So I did say you might have to use more than one rule, but maybe not. Sometimes you will. But that is a pretty typical algebra problem that you see a lot with exponents. So let's see, number 9. Try this one. Okay, number 9. And then while you're doing that, try 10. So on number 9, you see how all this is divided by all this. And by the way, this is a 4. Okay. So I would break, I'm not going to break this down. You can do this, breaking this part down. When I mean breaking this down, you will see in a minute. But what I'm going to do is I'm just going to go ahead and do things like this. 10 divided by 2. 10 divided by 2 is 5, right? I have 11 and I have 4. What was that rule? Subtraction, right? So I'm going to go 11 minus that. So 11 minus 4. Then I have y, 5 minus 3. And then what? Well, 5, what's 11 minus 4? 11 minus 4 is, see, 10, 9, 8, 7. And y squared. I do not want you to do 5 to the 7. And on a calculator, you could do 5 raised to the 7. That little caret on your calculator, in your calculator, this is that little caret. That little caret, that means a power, but don't worry about that. Okay? Look at this one, 10. Well, it's multiplication. Negative 10 and negative 10. Those are still the same. So, negative 10. But you're probably going to say, wait a minute. Isn't negative times a negative a positive? You are correct. But only for that. Because you have 4 up here of negatives. You have negative 3s of those. Power of those. So this is correct to be a positive. 10 times 10 is 100. But this is 10 to the power of 4. And this is to the power of negative 3. So this doesn't work. So this is going to be negative 10. And what are we going to do with these exponents when we're multiplying? We're going to go 4 plus negative 3, right? 4 plus negative 3. Or negative 10 to the first power. Or simply negative 10. Okay? All right. This gets harder. And as you will see, when we start doing radicals, the next part of this is when it gets a little bit dicey. So, Their next topic is going to be radicals. I will see you in the next video of that one then.